Today in Math 10C, we're looking at topic 2.7, the last topic in chapter 2 on trigonometry, and this is solving problems with more than one right triangle, starting on page 113. In example 1, we're asked to calculate the length of side CD. Well, we're going to call that side X. And if we look at this triangle, we'll see a right-angled triangle on top of another right-angled triangle. And the problem here is that we don't have enough information in triangle BCD to be able to figure out side CD, or X. So what we're going to have to do is first of all look at triangle ABD and figure out the length of BD, and then use BD to figure out the length of BD and the angle of 26 degrees for angle D to figure out the length of CD. So let's get started. Here we don't have enough information in triangle BCD to find length CD. However, if we found side BD from triangle ABD, we could use that side to find the length of CD. Step 1 is the bottom triangle. Let's draw that. Here we have A, we have D, and we have B. The bottom's 4.2, the top angle's 47. We need to find A, the length of side A. What we're going to do is, looking at that, and that's compared to the 47, we have the opposite side, and we have to find the hypotenuse. So we're going to say the sine of 47 is 4.2 over the hypotenuse A. Now what we're going to do is we're going to cross multiply and divide, and A has got to be 4.2 divided by sine of 47, and that's going to give me a side of 5.74. In step 2, the top triangle, we're going to use that length and 26 degrees now to say that, let's see, the cosine of 26 degrees has to be the adjacent side X over the hypotenuse of 5.74. Notice that I'm keeping this to 2 decimal places, and then my answer I'll report to 1. So what I'm going to do is cross multiply, and I'm going to get X is equal to 5.16 centimeters. Your turn. Calculate the length of XY to the nearest tenth of a centimeter. Well, XY is really side W, so we're going to call that W. And the missing side, X, from our first triangle is what we're going to call side X. Therefore, in that triangle, we're going to say the sine of 20 degrees is opposite over hypotenuse, or the sine of 20 degrees is X over 8.4. Cross multiply and divide, and we're going to get X is equal to 8.4 times the sine of 20, no dividing, and X is 2.87. And as I said, now we're going to look at W, side W. That's the side we really want to find. So we're going to say now the cosine of 22 from the angle Y is going to be 2.87, the adjacent, over W, the hypotenuse. W then is going to be 2.87 divided by the cosine of 22, and W is 3.09, or 3.1. And that's how you do it. In example 2, from the top of a 20-meter tall building, a surveyor measured the angle of elevation. Let's look at this. There we go. Let's hurry this up. The angle of elevation to the top of a building next door, and the angle of depression down to the bottom of the base of that building. Now that you know those two angles, we need to find out how far apart these two buildings are going to be. That's our first step. Then we can figure out how tall the second building is. So we need to figure out, first of all, side A, and then we can figure out side B. For side A, we have a 15 degrees. That's going to be opposite over adjacent, so tangent of 15 is 20 over A. Cross multiply and divide, and you're going to get A being 74.64 meters. Now, we're going to use that in figuring out B. This time, as I said earlier, don't round. We're going to get the tangent of 30 degrees is going to be B over 74.64. And when you put that over 1 and you cross multiply, you're going to get 74.64 times the tangent of 30, and B is 43.09. Now we know that the total height of the building next door is going to be 20 plus 40.3.09, and that's going to be 63.09 or 63.1 meters. In our next one, your turn. Determine the height of a taller building. Again, the same way. If that's 39, we got 39 there. We're going to figure out side A using the tangent of 39. Tangent of 42 is 39 over A. Cross multiply and divide. A is going to be 43.3. Now we're going to use that to figure out what side B is. And you're going to say the tangent of 31 is B over 43.3. Opposite over adjacent. And B is equal to 26.0. That means that our total height is 39 plus our 26, or 26.0, which is 65 meters. Your turn, number 3. Solve a problem with triangles in different planes. From the top of a 90-foot observation tower, a forest ranger observes one fire due west and one fire due south. One's at an angle of depression of 5 degrees, one's at an angle of depression of 2 degrees. How far apart are the two fires? Well, here's a picture of the scenario. Notice a couple things here. If the angle of depression is 5 degrees, by our Z patterns, the bottom angle is also going to be 5 degrees. And if the angle of depression of the other one is 2 degrees, that makes the bottom 2 degrees. Now, this also makes that angle a 90-degree angle, that angle a 90-degree angle, and the angle along the bottom right here is also going to be a 90-degree angle. We're going to need that to figure out how far apart these two are. And that's going to be our distance. So now, what we need to do is we need to figure out this side, and we need to figure out this side, and then use Pythagorean theorem to figure out the total distance. So that's the plan. Let's get started. First of all, our angle of inclination is the angle going up. The angle of depression is our angle looking down. And the angle of elevation of an object above the horizontal is looking up again. So here we have our two triangles. We need to figure out what x and y are. Well, in this example, I call them both x. And we're going to say the tangent of 5 is going to equal 90 over x, opposite over adjacent, and that gives me 1,028.70. And the other side, we got the tangent of 2 is 90 over x, which is 2577.26. Now our triangle that's on the bottom. We have 1028.7 on one side, and the other side is 2577.26. And we're going to use a squared plus b squared is equal to c squared. And that'll tell me C is equal to 2,774.98 feet long. And that's it. your assignment is to do page 118, 3 to 5, and 8 to 14. And this ends chapter 2 on trigonometry.